5.7 Enthalpies of formation. An enthalpy of formation, or delta H sub F, is defined as the enthalpy change for the reaction in which a compound is made from its constituent elements and their elemental forms. Standard enthalpies of formation. Standard enthalpies of formation are measured under standard conditions, 25 degrees Celsius and 1 atmosphere of pressure. Table 5.3 lists some standard enthalpies of formation. You can also find more in the appendix of your textbook. Identifying equations associated with enthalpies of formation. For which of the following reactions at 25 degrees Celsius would the enthalpy change represent a standard enthalpy of formation? For each that does not, what changes are needed to make it an equation whose enthalpy change is an enthalpy of formation? We need to examine each equation to determine first whether the reaction is one in which 1 mole of substance is formed from the elements. Next, we need to determine whether the reactant elements are in their standard states. In reaction A, 1 mole of sodium oxide is formed from the elements sodium and oxygen in their proper states, solid sodium and oxygen gas respectively. Therefore, the enthalpy change for reaction A corresponds to a standard enthalpy of formation. In reaction B, potassium is given as a liquid. It must be changed to the solid form, its standard state at room temperature. Furthermore, 2 moles of product are formed, so the enthalpy change for the reaction, as written, is twice the standard enthalpy of formation of potassium chloride. The equation for the formation reaction of 1 mole of potassium chloride is as follows. Reaction C does not form a substance from its elements. Instead, a substance decomposes into its elements, so this reaction must be reversed. Next, the element carbon is given as diamond, whereas graphite is the standard state of carbon at room temperature and 1 atmosphere of pressure. The equation that correctly represents the enthalpy of formation of glucose is as follows. For practice, write the equation corresponding to the standard enthalpy of formation of liquid carbon tetrachloride. Calculation of the change in enthalpy. Here we have a reaction in which a hydrocarbon, C3H8, which is propane, is combusted in oxygen and forming carbon dioxide and water. Imagine this as occurring in 3 different steps. So our propane would decompose into carbon, graphite, and hydrogen gas. Next, the carbon graphite would react with the oxygen, forming carbon dioxide. And third, our hydrogen gas would react with our oxygen gas to form water vapor. And then again, those 3 reactions would combine into the sum of the equations. We can use Hess's law in this way by taking the sum of the enthalpies of formation of the products minus the sum of the enthalpy of formation of the reactants, where N and M are the stoichiometric coefficients in the balanced chemical equation. These values, again, are found in the appendix of your textbook and are given as kilojoules at room temperature. Sample exercise 511. Calculating an enthalpy of reaction from enthalpies of formation. Calculate the standard enthalpy change for the combustion of 1 mole of benzene, C6H6, to form carbon dioxide and water. Compare the quantity of heat produced by combustion of 1 gram of propane to that produced by 1 gram of benzene. We need to write the balanced equation for the combustion of benzene. We then look up the standard enthalpy of formation values in Appendix C or in Table 5.3, and then apply the equation just previously mentioned to calculate the enthalpy change for the reaction. We use the molar mass of C6H6 to change the enthalpy change per mole to that per gram, and we similarly use the molar mass of propane and the enthalpy change per mole calculated in the text above to calculate the enthalpy change per gram of that substance. We know that a combustion reaction involves oxygen gas as a reactant, Thus, the balanced equation for the combustion of 1 mole of benzene is given here. And yes, you are allowed to use fractions. We can calculate the enthalpy change for this reaction by using equation 5.31 and the data table. Remember to multiply the standard enthalpy of formation values for each substance in the reaction by that substance's stoichiometric coefficient. Also, recall that the standard enthalpy of formation is 0 for any element in its most stable form under standard conditions. So that means that the standard enthalpy of formation for oxygen gas will be 0. From the example previously worked in the text, the standard enthalpy of formation is negative 2,220 kilojoules for the combustion of 1 mole of propane. In part A of this exercise, we determined that the standard enthalpy change is negative 3,267 kilojoules for the combustion of 1 mole of benzene. To determine the heat of combustion per gram of each substance, we use the molar masses to convert moles to grams. Both propane and benzene are hydrocarbons. As a rule, the energy obtained from the combustion of a gram of hydrocarbon is between 40 and 50 kilojoules. Practice exercise. Using the standard enthalpies of formation listed in table 5.3, calculate the enthalpy change for the combustion of 1 mole of ethanol. You can pause now or continue to see the answer. Sample exercise 5.12, calculating an enthalpy of formation using an enthalpy of reaction. The standard enthalpy change for the reaction is 178.1 kilojoules. From the values for standard enthalpies of formation of calcium oxide and carbon dioxide given in your appendix or in table 5.3, calculate the standard enthalpy of formation of calcium carbonate. We need to obtain the standard enthalpy of formation of calcium carbonate. We begin by writing the expression for the standard enthalpy change for the reaction. Again, it's products minus reactants. We insert the given and known values, and then simply solve for the heat of formation of the reactant, calcium carbonate. We expect the enthalpy of formation of a stable solid, such as calcium carbonate, to be negative, as we obtained. Practice exercise. Given the following standard enthalpy change, use the standard enthalpies of formation in table 5.3 to calculate the standard enthalpy of formation of copper oxide. Again, you may pause the video now or continue to see the answer.